Okay, use of calculus in real life situations. So this is a very vast topic. A lot of you will go into some of this in much more detail than we're going to touch on in higher maths, depending on kind of what route you go down. But calculus is used massively throughout sciences. So in physics, things like Newton's law of motion, we go into that. Kind of more into advanced higher Einstein's theory of relativity. In chemistry, looking at reaction rates, radioactive decay, biology, things like population, medicine, economics, engineering, just lots and lots and lots of different branches. We're kind of looking at the pure side of maths. Calculus is so fundamental in all of these. Now, some of you will do physics, and you'll know the formula for kinetic energy and momentum or that. Now, these are related to each other. Okay, so if we have kinetic energy and we want to get momentum, what we do is we differentiate. Okay, they're called related rates of change. If we have the formula for kinetic energy, momentum, and we want to get kinetic energy, we integrate. Okay, so they are related to each other. The more common one is displacement, velocity, and acceleration. So think of displacement basically as a journey. It's a vector. It also has a direction, basically. So velocity and displacement are basically, they have directions to them. So the speed is like an instantaneous speed, but the velocity is where does it take place. So the connection between them is displacement differentiates to velocity, and that differentiates to acceleration. And then obviously to go back the way, we go acceleration to velocity to this. So the way to remember it is dVA. Okay, displacement, velocity, acceleration, we differentiate. Going back the way, we are going to integrate. It's all about, the vector equivalent is all about the actual distance itself plus the position plus the direction that it is going in. So the displacement of a particle moving in a straight line is given by that formula. Find its velocity after 3 seconds. So we have the displacement. Now, if we're setting this up, there's kind of 2 ways we can explain it. Obviously, V for velocity. Now, what we're doing is we are differentiating, right? Remember, dVA. So it's ds over dt, because that's what we're doing. We're differentiating the displacement with respect to time. And we're going to differentiate this. So 3t squared minus 4t plus 3 at time is 3. I'm going to sub that in. And then we're going to calculate it. Now, obviously, if it was non-calculator, let's just do it in stages. It's 18. Now, we're in centimetres per second is what it's saying. So centimetres per second. Remember, you can also write it to the -1 if you'd rather that. Okay, the time at which acceleration is equal to that. So how do we get acceleration? We differentiate the velocity with respect to time. So what is our velocity? Our velocity is that there. Okay, so we're going to differentiate this. So we're going to get 6t minus 4. Now it wants to know the time at which it's equal to 26 centimetres per centimetre squared. So 6t minus 4 is 26. 6t is 30. So t is 5 seconds. Okay, example 12. The velocity of an electron is given by that formula. Find the formula for the displacement of the electron given that when s is 0, t is that. Right, so we know velocity. We're going back to displacement. We are integrating. So it's not as obvious this time. It's not explicitly saying it, but we need to know that we're integrating to get from velocity back to displacement. So our displacement, s, is the integral of velocity 2t minus pi over 4 dt, because we're integrating with respect to t. Okay, so let's integrate this. So s equals So SC negative S negative C. Sine integrates all the way to negative cos. So negative 5 cos 2t minus pi over 4. Differentiate inside your bracket, you get 2. So we're going to divide by 2 plus c. Right, what do we know? We know that s is 0 and t is pi over 8. So s is 0, t is pi over 8. So let's chuck that in. 0 equals negative 5 cos 2 times pi over 8 minus pi over 4 over 2 plus c. 0 equals negative 5 cos. Now, 2 times pi over 8 is pi over 4. That's going to give you 0. Cos of 0 is 1. So c is in fact 5 over 2. So our formula for displacement is negative 5 cos 2t minus pi over 8, pi over 4, all over 2 plus 5 over 2. Obviously, you could put the whole thing over 2 if you wanted to, but it doesn't really matter. Okay, so that's a more slightly complicated example. It's about knowing to get from the velocity back to displacement. We integrate, we have to set up that integral, work through it using your chain rule, sub in your values, and then finally get your answer.